Okay, this is part 4, and I'm now moving on to the second set of slides. And we're in the book, starting with hypersensitivity type 3 reactions, immune complex mediated, on page 444. So what is an immune complex? That's the first thing. An immune complex is formed when antibodies and antigens get together and they stick in these clumps, as you can see here. The two important kinds of antibodies that do this, sticking together, are IgG and IgM. IgG is that monomer, that single Y shape. Our IgM is our pentamer, made up of 5 Y shapes. 1, 2, 3, 4, 5. And they can stick to antigens on their arms, and then other antibodies can stick to them. And then this whole thing, after many antigens and antibodies have stuck together, is an immune complex. The ability of immune complexes to form, and in particular the size of the immune complex that forms, is based upon how much antigen and how much antibody there is in circulation. If there is more antigen than antibody, if the antigen is in excess, then we start to form smaller immune complexes. And it's the small immune complexes that are of particular concern in our type 3. These complexes can remain in circulation, they get floating around the body in the blood, or they can form or they can lodge at the site of formation. And if they are circulating, they can then lodge in various different places. They can lodge in blood vessel walls, they can lodge in skin, in joints, and in the kidneys. And then these immune complexes are the targets for a vigorous immune response, and that's where the damage comes from. So continuing on our our pictures here, we have the immune complex triggering an immune response. In this case, we have basophils. Basophils releasing inflammatory mediators. Inflammatory mediators having all those effects on the body that we've talked about before. In this case, in particular, making the blood vessels more leaky. You can see the gaps forming here between the blood vessels. And then our immune complexes can get stuck in those gaps. They get lodged in the walls of the blood vessels. In addition to making the vessels leaky, we have the recruitment of other immune cells. In this particular example, we have the recruitment of neutrophils, and then one of the damaging impacts of neutrophils is the release of toxic chemicals. The toxic chemicals are released in an attempt to destroy the antigen, but at the same time they have a detrimental toxic effect on the surrounding cells. So our immune complexes form, they get lodged, an immune response is mounted, cells like neutrophils come along and release toxic chemicals, destroying the antigen, but at the same time harming our own cells. So all of the effects of immune system activation occur, triggering blood clotting, activating the complement system. In this particular case, we are looking at the recruitment of phagocytes, neutrophils, that release their toxic molecules. So looks like everyone around me has decided to mow their yards, so I hope that isn't going to be too much of an inconvenience. We can see, as a result of these immune complexes forming, as a result of them getting stuck in various parts of the body and triggering an immune response, we can see rashes, joint pains, symptoms of farmer's lung, systemic lupus. We'll take a look at lupus a little bit later on too. Bacterial endocarditis, early rubella infections, malaria, all of these different things. One of the effects that they have is through causing small immune complexes, triggering the immune system, and then having damage to cells. And that damaged cells starts a whole other cascade of the immune response. One response coming from type 3 hypersensitivities can be this disseminated intravascular coagulation due to clot formation in small blood vessels. So this is where clotting and inflammation and immune response are all linked. What we have is we have the formation of the immune complexes, the activation of the immune system and inflammation. That leads to lots and lots of small clots being created in the blood. Those small clots can go away, and they can cause problems themselves by clotting up small blood vessels. But in addition to that, all of this excess clotting, all these little clots, they use up all of the clotting material. And so when there is damage to the walls of our blood vessels and blood starts to leak out, there are no remaining clotting factors to put an end to that bleeding. So we get uncontrolled bleeding. And in the other example we looked at, you can get, you bump yourself, you get a big nasty bruise because those fine capillaries have been damaged, but there are no clotting factors around to stop the bleeding. We saw it caused by endotoxin. They can also be caused by transfusion reactions. So a lot of overlap in a lot of these mechanisms. All this clotting and bleeding can lead to failure of vital organs, and it can lead to, as I said, excessive bleeding. Disseminated intravascular coagulation is a systemic disease. That's where the disseminated part comes from. There are also examples of localized immune complex reactions. The Arthus reaction occurs following injection of an antigen into a previously immunized individual. So if you've already been immunized, you're going to have, the whole point of an immunization is to trigger an immune response and to trigger the formation of antibodies in many cases. So after an immunization, you're going to have circulating antibodies in your blood. And when we have an injection of antigen, that's a lot of antigen, and when also there are high levels of the antibody, that's when we set up the conditions to form those small immune complexes. It happens at the site of the injection because that's where this high level of antigens are. So the injection goes in, the antigens work their way into the tissues, start to form those immune complexes, and then all of the results of inflammation and increased blood supply and increased leakiness and swelling all happen at this one spot. So, for example, when a tetanus diphtheria booster is given too often, you can get the Arthur's reaction. Antibodies cause immune complexes at the site of the injection. Neutrophil enzymes are released, causing local inflammation, and you have hallmarks of inflammation with pain, swelling, and redness. A systemic type 3 hypersensitivity that can occur is serum sickness. This is caused by passive immunization. So sometimes you get maybe a toxin, and an example that you might think about is getting bit by a rattlesnake. If you get bit by a rattlesnake, you have an injection of toxin into your body, and the toxin is very fast acting. You don't have a chance to mount an immune response against that toxin and also combat it. You either are very sick or you're killed long before your immune response has been able to build protective antibodies. So you get an antivenom as a kind of a stopgap, quick method to eliminate the toxic effects of the rattlesnake venom. That antivenom comprises or consists of antibodies, pre-made antibodies. And those pre-made antibodies typically come from another source, not a human, and sometimes often it is horses. Horses are big, they've got a lot of blood, therefore you can get a lot of antibody from them. However, even though horses and humans are both mammals, our antibodies are going to be very similar, but the antibodies made by the horse to protect us from the snake bite are themselves going to be recognized as foreign. The composition of the antibody made by the horse has the wrong shape and is therefore recognized as our bodies as being non-self. As a result, then, we mount an immune response, and that immune response will lead to the formation of these immune complexes, and those immune complexes will lead to all the damage that is indicative of these reactions. It is systemic because when you're given that, say it's the antivenom is then spreading all throughout your body, and that means that you can form immune complexes all throughout your body, and then you can target inflammation throughout the body. But it's a side effect of a sometimes needed treatment when there is a high risk of infection and insufficient time, or not just infection, a high risk of detrimental conditions or even death in the case of the snake bite. We can also use passive immunization to bolster the defenses of people who have become immunosuppressed. Okay, so type 3 on slide 7 here. Know what immune complexes are and when they form. In particular, know the significance of the amount of antigen compared to the antibody in terms of the size of the complexes that are being formed. Smaller complexes are the ones that cause problems in particular. The damaging effects then, many damaging effects: release of toxic chemicals by phagocytes, clotting, activation of the clotting cascade, and leading to disseminated intravascular coagulation, and then all of the subsequent harmful effects that can cause. Disseminated intravascular coagulation, we've talked about that a couple of times. Arthur's reaction, a localized reaction when you get an injection of antigen. A good example is a tetanus diphtheria booster given too often. And then serum sickness is a systemic condition caused by immune complexes. Under certain circumstances, you get this shot of passive immunization. You get the shot of non-human antibodies, and then those non-human antibodies are themselves, although they deal with the short-term problem, they themselves are the target of an immune response, and they themselves can trigger the formation of immune complexes.